Good morning. Today we'll be working on a Rust command line application that will take in a JSON Web Token like this and decode it into its parts, header, payload, and signature. The finished application will be called JWT check. It will take in a JSON Web Token as an argument like this, and when you run this application, it will give you its parts, header, payload, and signature. This application is simple enough to be finished in one sitting, yet it touches upon many fundamental Rust software development concepts. If you like the video, please do make love with the like button and consider subscribing to the channel. Let's start with creating a new project. So cargo init, then this creates a new project in the current directory. Then let's open the main file. We want to create a command line application for decoding JSON Web Token. For making command line applications, we'll use a crate called clap command line argument parser, which makes this process of making command line applications very easy. Here is a crate. So excuse me. Let's copy this. What I've done here is that I have prepared some code snippets in advance to make the coding run a bit faster, because you're not here to see me type. So I will copy paste the same thing, this part, as a snippet that I have prepared previously. Let me copy paste it. Here we are creating an argument whose short form whose short form is t, that is minus t, and long form is minus token. That's how you will pass it at the command line. And then it takes a value, and then it is required. That is, if we do not provide this particular argument minus t, we are going to receive an error. Okay, and then whatever value that we pass from the command line, that we can get access to that value through this line, the value of token. And then this is for error handling. So in case if you do not provide any token, it will just give an empty string. So now we will do our processing in a function called, let's call it parser. Function parser. It will take string as in stir. Okay, let's make a stir, and it will return a result. The result would be a JWT token, which should be a data structure that will create on a minute, and JWT error, the error data structure. Okay, unimplemented. Let's quickly create. In the meantime, let's bring in the crate. Cargo, I use a utility called cargo add to add dependencies. You can alternately add them by hand in your TOML file. Here it added this dependency here. I'll just remove the patch release and build it. Cargo build. I have an alias set for this. It saves me a few keystrokes, just CAB. Okay, so we will, let's bring in the crate as well. We will need, I think the boilerplate that we need to bring the crate in is, what is it? This. Copy. Okay. We don't need this part. Good. Okay. Now let's quickly create the data structures for JSON Web Token. So struct for the fields. Let's take a look at what the fields of a JSON Web Token are. So here is a very nice site, JWT.io, to generate some demo web tokens. It has got the JSON Web Token has got three fields: header, payload, and signature. You see here, header. This is header. This is the payload, and this is the signature. All three of them are base64 encoded. So we will name the field as header, which will be of type string, payload, which will be of type string, and signature, which will be of type string. Okay. Then we will also create the error struct. So again, this time we'll make it an enum because it is going to have variance. So okay, so few errors that we can think right off the top of our head is missing part. If any of the header, payload, or signature is missing, or an unknown part. If we end up giving unknown part, if you end up giving more than 3 parts to our JSON Web Token. Let's also quickly implement the standard error trait on this. It's really simple to do that. std error for JWT error. That's it, and you have implemented this standard error trait. It is going to complain because when you implement this trait, it requires you to implement display trait. Let's quickly do that as well. So impl std display for JWT error, and then this takes, this is a very standard formatter function. Then here we will give all the variants of the error. So our error variant is, one of the variants is this. I will throw in a format here. Error missing part. Okay. Then we'll say JWT. This is for the unknown part. Okay. Error. Okay. Result failed to format result. Okay. All right. So what we will do is we will, just to make our life easy, we will steady FFT. Okay, steady, let's make it this way. FMT IO. And right here, it's always good to return an error type. So from the main function, you return a result like this. And of course, right now it's going to complain because it expects this function to return a result type, but right now it returns nothing. So we'll give it this. So right now, if everything goes fine, our function returns empty. It's called a. So now is everything okay? Any errors here? We can remove this here. So far so good. Okay, we have this function. Let's call our function parser in our main function. So let token is equal to parser, and here it will take this input as token, and if it returns an error, we'll do an error handling through the question mark operator. Probably, yeah, it'll right now give an error because couldn't convert error to stdio error. We will do this conversion shortly. So let's do the conversion here. So to do this conversion, let's think what we should do. Let's to do that conversion, we have to implement a from trait for that error. So implement from, and here you give the error type from which you want to convert. So here it was complaining about, if you come here, it was complaining about steady IO error. Was it that? No, something went wrong, sorry. Couldn't convert, stdio error. Okay, so we will convert this stdio error to JWT error. We are returning, our program returns this IO error, or let's return JWT error from our function. Instead of returning IO error, yeah, let's return this error. Okay, so yeah, now we don't need to implement IO error anymore because we are returning a JWT error instead of an IO error. Okay, so now let's build this parser function. So our parser function will parse the token that it received from the command line. In this line, it'll take in that token, it is going to parse it, and then it is going to convert it into this data structure. So for doing that, we will have header. We are going to parse in this function parse error. We're just making a wireframe for our application. So this is going to take let's give it, it is going to take let's call it O, and it will take some type, let's call it all, and let's call it, let's say it takes star for now. We will change it later as we start implementing it. And it is going to return a result type again, and that result type is going to be, what shall it return? Let's say it returns string, and error would be JWT error. Unimplemented. We will do exactly the same with the payload and signature. Payload and signature. Okay, so our wireframe is nearly done. Do we need to do anything else off the top of our head? I can't think of anything else. We'll add other things as we develop the application. So then let's start implementing it. So what we do first, when we receive this token from our command line argument, is we are going to parse it, and we are going to break it into header, payload, and signature. So to be able to do that, how do we do that? Let's use the split. Okay, let's do it like this. Let splits is equal to, we say JWT, which is the input argument, dot split. We'll split it on a dot because the JSON Web Token is separated by dots. All the components in a JSON Web Token, they are separated by a dot. This is going to return, I think this returns a result type, right? No, this returns an iterator. Yeah, this returns an iterator. Okay. This returns an iterator. So we are going to pull the stuff out from the iterator like this. Let header is equal to let's call it parse header. Let's say split dot next. Is it split? It splits. Okay. Splits. Okay. It is splits dot next, and this most likely will return. What does it return? It returns a result type. Here you can see in the help tag here, a result type. So we'll have to do some error handling. So we will do error handling with question mark operator. Okay. Mismatch type, found enum. All right. So this iterator, when we pull the value out of that, it returns, the iterator returns an option type. But this function, it accepts a stir type, so let's change it to option type, shall we? We'll call it an option of type and stir. Yeah, looks good. We will do exactly the same thing here. Okay. Okay. Let's go right here. Let's do the same thing here. Okay. That's good. Mismatch types. Found unit type. Okay. Let's still keep this here so it doesn't complain. Splits, can't borrow splits as mutable. All right, of course, because we are pulling values out of the iterator, so this has to be mutable because we are mutating over this particular variable. So let's pull out the payload as well. Payload. All right, we have pulled out the payload, and let's pull out the signature. Okay, now if there are more than 3 parts in a JSON Web Token, well, let's return this unknown part error in that case. So how shall we deal with that? Let's say, how to do that? Let's say if splits, then we say next. If splits dot next, then let's use it like this. Okay, let's do it this way. Okay, then in that case we will return this error. You can't straight away return JWT error. It's good to encapsulate it like this, because we are returning a result data type here. So a result data type has 2 options, either an OK or an error. So this will be encapsulated in an OK, and this will be encapsulated in an error. JWT error, like this. Okay. All right, then beyond this point, once we are beyond this point, we have got a good header, we have got a good payload, and we have got a good signature. We have already successfully parsed a header out of the given JSON Web Token. This will give us a payload, and this will give us a signature. So then we will create a JSON Web Token out of it and return it. So JW token, we will create header. Let's do it the long form. Actually, you can do it in a short form like this: header, payload, and signature. Let's keep it like this. I think we'll need it later on. Header, payload. As we develop this application, you'll see we are going to need this way. Signature. Okay, yeah, you see it right now. It is complaining that you can use a shorthand version, just header, payload, and signature, and avoid this part. But we will get to use that full form. Okay, so for now it's okay. Now let's quickly implement the header. So right now what we'll do is we will just return, we'll just unwrap, because we are getting it as an option. We'll have to unwrap it, and then we'll just return the unwrapped string for now. So let header, let's say let data is equal to option dot let's call a match here. Match. Okay, so if the match, if there is none in it, not none, there's none, then what do? Then we just say we return this error, JWT, then well, this part is missing, so it's an error, missing part error, and then some part, So now we are using sum. We are able to unwrap this the value inside the option. So this part is going to be an answer data type. So let's return the part. Right? No, this is going to complain because this has to be inside here. Inside an OK. Okay. Let's remove for now. Let's remove this part. Expected string found stir. Okay. Dot to string. Let's make it this way. Okay. Let's put the same thing here. Okay, so let's go up. We're not using this, let's remove this. If you're not using it, we don't want unused stuff polluting our code. Okay, this we will use in a moment. Okay, let's use it right away. So we will print it out like this. Decoded token is this. Let's pretty print it. So it is going to be token. Okay. Right now these are not highlighted because I think we're not using them. Let's see if you're not using. Okay, that is why there's a misprint here. Okay, payload, parser payload, signature. Okay, all right. I think we have written a fair amount of code, so let's try to run and see if everything is working. We are going to build it to see if everything is okay. Okay, this is, as I told before, this is my alias CAB for cargo build. It does exactly the same thing. Now let's run it. Cargo run. For this also I have an alias called car. It saves me a few keystrokes. Okay, so right away you see this this command line argument parser. It is helping us. It is saying that you cannot run this application without providing this required token minus token. If you remember, we made this required. So let's pass this as an argument. Cargo run. This is how you pass an argument when you're developing. Like along with cargo run, when you use cargo run, you pass the arguments like this -t, and then we will pass something for now. Okay, so it took our argument. Anything that you pass after this two dash, they go as arguments. So it has taken over this argument that we passed with the command line, and it has converted it into a JSON Web Token and printed it here. Okay, all right. So let's get started with decoding the JSON Web Token. So let's take a look at how a JSON Web Token is, how a JSON Web Token looks like, or is it what a JSON Web Token looks like? I think that's the right way to say it. Okay, so a JSON Web Token looks like this. If you see here, this gobbledygook, this is nothing but this JSON, which has been base64 encoded, and this gobbledygook is this, which is base64 encoding. And I should point out that base64 encoding is just encoding, it is not encrypting. Anybody who can, anyone who can get a hold of this JSON Web Token can just run a base64 decode and decode it back into this form. So you should not put any sensitive information inside a JSON Web Token. Okay, let's move on. So let's steal this JSON Web Token from here, and let's put it I'm avoiding to keep running the application here so as to test it while we are developing it. Instead, let's just write a test, and that way it will save us a few keystrokes. Otherwise, every time we write some code, then again we have to go back onto our terminal, enter the whole big JSON Web Token, and then run it. It's a bit of a hassle. So let's do it this way. Test, and our test, let's call it, what shall we call it? Parsing success. Okay, let JWT is equal to, here we will give it the JSON Web Token that we copied from that website. Jet. It is not jet, it's JWT. Okay, so from this test, we're going to call our parser function. So let token is equal to parser, and to that we will give JWT token, and it is going to return a result, as you can see here. So we could have given a question mark, but then we'll have to do error handling here in the test. We will have to, this test is going to result in error type. It doesn't make much sense. So let's just unwrap it here, and if the test fails, then we'll just panic, which is just fine. Okay, then we will say what is the expected. So the expected is going to be this. Let's copy this value from here. We copy this, cabe, and we paste it here. We say let header is equal to, because this is JSON, let's keep it in the raw format, otherwise we'll have to do a lot of, we'll have to serialize it by hand, which is a bit of a pain. Okay, if we hadn't used the raw format, we'll have to serialize it by hand, because it's got all these, by serializing I mean we'll have to put a lot of these backslashes here, and it won't be cool. Okay, so as you can see, the expected value, this is JSON. So we will have to convert this string into JSON. So this is provided by a crate called serde, this sort of conversion, serde JSON. So let's bring in that crate. Cargo add serde, you will need 2 crates. Serde is serde or serde, I don't know what is the right pronunciation, probably serde. So serde is a low-level crate which provides basic framework for doing this work, and serde JSON is specific to serialization, deserialization of JSON. It provides the JSON specific bindings. So let's bring in both of them. We will check our TOML file. So you can see they got added here. Let me remove the batch releases. Okay. All right, now let's build it. So now we have to, let's think how to convert it. Okay, we will convert it like this. Why does it look awful? Okay, much better. Okay, so let, what we will call it, let header is equal to serde JSON. We will convert it, we want to convert it from string star, this is a raw string star. So I think serde JSON provides us from star. Let's check the documentation. Where is serde JSON? Serde JSON, yeah, it is. We want to convert it from star. Is there a star method? Ah, here, this is what we want. So serde JSON from star, how do they use it? From star, and this is the JSON that they're giving here. This is the JSON that they're giving. And then because this returns a result, probably this, yeah, this returns a result type, so you do the unwrapping. We will do exactly that here. From stir, why am I not getting IntelliSense? Okay, let me reload my Rust analyzer. Okay, header. This will return an error type, so we just unwrap it because it's a test. We don't care about error handling. There's a problem, let it panic. Type annotations needed. Consider giving header a type. Alrighty, sir. Type annotations. Let's look at the documentation. Unwrap. Oh, okay. It has the ability to unwrap it into a specific type. So let's unwrap it into JSON because we want JSON out of it. Serde JSON value. We will unwrap it into this format. Yeah. In case if you find this way of specifying a type ugly, we can use turbofish, which is like this. Let me just quickly show it to you. Value, okay. And then the same thing. So this way, when you specify, it's called, this thing is called a turbofish. Because from star is so generic, you have to specify a type. Like from star essentially means that from this string you are converting it into something. It can be anything. It can be JSON, it can be some specific data structure to which you want this to be converted to. So you are what you are doing is you are doing a deserialization into a specific object. So you have to provide what type of object you want to deserialize this string to. So here through turbofish we have provided that type, which is, this is the JSON type. So we are good here. then this becomes our expected value. So let's put in an assert here, assert eq, then we'll say header, and we got our this is our JSON Web Token. So token from here, this token has a header, so we will compare with it for equality. Right now I think it is going to fail because this token header is string type, string with a capital S, and this is a JSON type. This is going to fail. Let's run the test. Okay, it failed because the left is this and the right is this. Obviously it is going to fail. The left is a JSON, this is JSON type, and the right is the string type that we are providing here. It just right now just takes this header and gives it back to us. Okay, and I was able to run this because I have got some what do you call that, shortcut setup. You can do exactly the same thing by running a cargo test. Does the same thing. Okay, it just saves me a few keystrokes, and it saves me the hassle of going back to the terminal and doing it. All right, so now let's try to do some refactoring. If we go up, let's see if something needs refactoring here. Okay, here, if you see here, this function parser, this is our, you can think of it as a public facing function. If we wanted to write a documentation for our library, which is going to be used by external users, our users do not need to know internal implementations like how are we decoding a parser header or a parser payload, but this function we might want to include in our documentation for the for third-party users who are like not really interested in how we implemented the library. And also this particular function is going to be very useful if you wanted to export this application as a library, which can be called by somebody in the code. So then they will be using directly this particular function. Obviously we'll have to preface it with pub to make it public, so that people can use it. And these are our private functions. They wouldn't be visible outside, and we keep them private because these are internal implementation details. Okay. For now, when we are creating this application, we don't really care about making it public or private. We are just creating an application right now, so we'll just keep it this way. But this function parser, it is good to keep this as generic as possible. Right now, it expects a concrete type, which is and stir. So let's make it more generic. So we can do it this way, as stir, I think it is, as stir, what is it, is it as stir? I think it is this. Let me just first put it and then I'll, oh sorry, it is as ref. I think it's as ref. Yeah. And it is this here, and it is this. Okay, then the only change we need to make it is we have to say as ref here, and we're good. So this small change, what the difference that it has done is that now we'll be able to accept any object of type T so long as that object can be converted into and stir. And this particular trait, this is this way of doing things is we call this giving a trait bound. As ref is a trait, so if any external object implements this trait, this particular trait as ref stir trait. It means that particular object can be converted into an and stir representation, and we'll be able to accept that object as an argument, and as a result this function becomes more generic. It will be able to accept wider variety of arguments, which is always good for a public facing function like this parser, though in this application we are not calling this public. That taken care of. Is there anything else we would want to do? Okay, so as we saw here, our ultimate goal is to convert these string types into JSON types. So for that we'll need serde JSON, and then we also, because this particular token, JSON Web Token, is base64 encoded, so first we need to base64 decode it and then convert it into JSON. So let's also bring in base64 crate. Cargo add, I think it is called base64. I think it's base64, right? Let me go verify it. Base64, yeah, it is called basic. This is a crate, yeah. Okay, base64, let's build it so we can use it in our code. And reload my Rust analyzer. Let's start really implementing the header. So now here in this part we are no more just throwing back the string that we got in the argument here. Now we need to base64 decode it and then convert it into JSON. So for that, what we will do is we will say how do we decode that? Decode, I think we will need this part. Okay, just a quick recap of this base64 encoding and decoding. So base64 is an encoding format. You encode or decode using configurations, because there are multiple different ways in which you can base encode the same thing, the same string. You can use either a standard config or URL safe config, or you can roll your own config. In JSON Web Tokens, we use URL safe configuration. Then this is how we do encoding and decoding. We will be using this because this by default uses standard config. We want to use URL safe, so we will use this one here. I think you will find it say this here wherever they're showing the example. Yeah, you see here, decode, it uses internally it calls this decode, internally it calls decode config with this config. We'll use this. We will use it exactly like this. Let's copy it. This is for base64. We want URL safe. Copy. Okay. Let decode it is equal to Control Shift V. Okay. Base64. Then we will need to convert this into JSON. Let decoded is equal to how do we convert this into JSON? I think we already did it. Yeah, I don't need to go back to documentation. I think I did it here. I'll just steal it from here. Okay. Why the hell is it complaining? Okay, alright, yeah. Then we'll say okay, and we'll return this decoded value, and of course it is going to complain right now because here we are saying we are returning string, but in fact we are returning a JSON value. So let's change the format here. We'll call it serde JSON. Darn, too much typing. Let's bring in this crate serde. Let's bring in that particular struct and scope value. Okay, here struct serde JSON. Yeah, we were here. Here is a value. It's happy now. Error. Alright. Decoded. Is it happy now? Answer. Expected reference answer. Found vacate. Ow. Okay, so here it is not from star. I think we'll have to, the thing is this decode config, I think this returns bytes. Yeah, you see here, this returns bytes. Yeah, you see, no, not here, this is the input argument. This returns a whack of bytes. U8 means bytes. So this from star won't cut it. I think we'll need something that converts a byte array into a JSON. Let's go back to, where is that? Serde JSON. We'll need something to convert from bytes. Serde JSON. Let's say from UDF8 from serde JSON. Serde bytes from back. So I think we will have, as we see here from the documentation, we are not able to find anything that converts from bytes to JSON. So let's do, I think we will have to convert it using star. We will use the star library to convert bytes into string. Okay, let's do that. You will see what I mean in a minute, because I know this provides from UTF-8. UTF-8, this is your star standard library. You see here, this provides this. So we will steal this star. We'll do exactly this way. What this, it takes a reference to a byte array. All right. What is it decoded? And here, decoded is, as you see, it's an owned vec of U8, so we'll have to pass and decoded, and we will make it, instead of making it serde JSON, we will say, first of all, let's get rid of this star. from UDF8, decode it, expected, yeah. So let's convert it, because you see here it complains it needs a reference to a slice, whereas we are passing an owned object. So it's very easy, just say and here. When you put an and, it converts it into a slice of an array. Okay, so right now it is still complaining that yeah, obviously we have to do that. We have to now do the conversion that we were doing there. So we'll say let decoded. Decoded is equal to serde value. No, what am I doing? Serde JSON, and it's serde JSON. How did we do that? From stir, yeah, it was from stir. From stir, decoded. Is that it? Okay, so this is value. This expects value found and stir. Serde JSON. Let's copy this. Decoded. I think this particular turbofish shouldn't be required here, because it should be able to infer the type from here, because we're returning this here. Let's see, expected enum value found. Oh, okay. Yeah, so we have to do error handling here. So finally we are forced to do error handling here. Let's just make an unwrap here, then we will do a proper error handling. For now, let's just see if it is doing it proper. And obviously here we will have an error, because our types are string, whereas here we are returning a value type here, a value type which we are using. We are returning a value type here, and we are taking this value type and trying to make a data structure out of it, but this is going to complain, because this JWT web token right now, the header, payload, and signature field, they are of type string. So let us convert that to value. I think we can give value directly, because we have already brought it in scope. Value. Did it complain? It did. Okay. Now I think this signature in the end. Let's go back to the specification. How is the signature? Yeah, the signature actually, I think it remains as bytes. Yep, the signature is supposed to remain as bytes. Signature is something that is used for verifying whether JSON Web Token has been tampered with or not. So the information is contained only in header and payload. Signature is just used for verification. So we will just leave signature as base64 decoded as bytes. I'll change it to wake off U8. Okay, it is going to complain, but we're going to fix it pretty quickly here. Let us first fix this part, signature. We have to make this, we have to return bytes here. So we will copy this part here and we will paste this here. Let's just say some part of decoded is equal to base64 decode. Here we will part. Okay, this is the thing that got decoded. This is the decoded value, and then we're just unwrapping it. We're not doing any error handling, and then we return this decoded value, and we change this to vec of bytes, and we remove this. Here is good, and we'll have to do this thing for both header and payload. So let's refactor it into a separate function, shall we? Yeah. Let's create a function so that it avoids code duplication. Function, let's call it process part. Okay, and it will take part which is of type what, which is of type this, which is of type part is of type answer, and it is going to return a result of type value, and error as JWT error. Okay, and inside here we are going to bring in this. Yeah. Let's just copy it, paste it here. Okay, good, decode it. Let's also remove this junk from here. We call it, what was it, part. Good here. Here this will give us the bytes. This will convert the bytes to string, and this will convert from string, from stir. This will give us a stir, and this will, from stir, it will convert it back into a JSON object. We had to do this extra part because serde JSON doesn't provide us a way to directly convert something from bytes into a JSON object. That's why we had to do this in between part. Fine. Then we come here. We move this. We call this function. We call this, okay. Let's call it this way. Let result. Let's say let decoded. Decoded equal to process part. Because this returns an error, we'll have to do error handling. So I'm putting unwraps everywhere because we will get to error handling right after this. This, as you see here, it returns a value. So, and this also returns a value, so we're good. So we just have to return this. What was it? Decoded, I think. Decoded, right? Yeah. Why? Okay, it will also complain because we are saying we are returning a string. We convert it to value. Are we good here? Okay, let's see. Everything is good or not? Any errors anywhere? No errors anywhere? Why does it still complain? Okay, is it still complaining that it is used shorthand format? That's fine. This is value, 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 signature. Okay, I think now we can use that. Okay, so my assumption I was thinking that I might have to use it. I might have to use the longhand version, but turns out I don't have to use the longhand version. So I'll just follow what Rust Analyzer is suggesting and use a shorthand version. Anything else is needed? So far it looks good. Let's try to run this test and see what happens. Woohoo! Wow! Haha! Our test passed. Let's make sure that the test really is doing what it is doing. I'll put in some breakpoints just to make sure things are working the way they are. You don't have to do this. You can just put up some print statements if you don't have a debugger. I just find straight away using a debugger a bit more easy in some scenarios, not all scenarios, particularly in this scenario. So let's bring in a debugger just to make sure that things are working okay. Fine. Run to the next breakpoint. Okay. F10. Did it decode? Did it decode? It did decode, I guess. Yeah, we are seeing some data structures here. Good. It didn't panic, first of all. So yeah, it didn't panic here. It did decode. Good. Good. We'll run to the next breakpoint, which is in payload. We'll do an F10 here. Okay, it didn't panic. It is good. Let's just go here just to make sure. Yeah, it has got some. This is a data structure, so you will not be able to see the internal values. But yes, this step went okay. So let's run to the next breakpoint, which is in signature. Let's F10 here and decode. You can see here this is the what do you call unwrapped value that is here. This is the unwrapped value, and it got decoded to a vec8 of something. Because vec8, the things are on the heap, you won't be able to see them here. But this decoding process, it went okay. And also because the this unwrap it, otherwise it would have panicked if there was some problem here. F10, F10, good. We came here. We are creating the token now. We're returning the token. This returns the token. You can see here we got the token here. This is the token. Okay. Then we converted this token from this string format directly into a JSON object here. This is a JSON object. And here we are asserting it, and it passed. Our test is really working. And close the debugger. Woohoo! Okay, so now let's quickly do some error handling. So we will think about the error handling, what different errors are possible here. So we are using, let's go back a bit here to this particular function. These functions are pretty bare. We're just calling process part. So the bulk of the processing is happening here. Here we are doing two things. We are doing three things here. We are doing decoding from base64. So this particular library, this particular crate will have an error type. We'll have to handle that error. Then we are doing this conversion from string. So we'll have to handle any error that might get thrown from this stage. And this serde JSON, this particular crate, we are using this and we are converting this value from string to JSON object. So in that conversion, if there is a problem, then we will have to handle that error. So these three errors, we will have to handle these three errors. Let's take a look at what the respective errors are. We will just go to the standard library quickly and base64. But if you want to see what an error struct looks like, I generally go straight to here to the structs. I go here, base64. I go straight to structs, and oftentimes I get lucky. Structs, bummer. This time I didn't get lucky. It often shows me what error is in a lot of crates. So here it returns, it returns that this is the error, decoder. This would be the error because we are using this function decode config. So this is the implementation of this function. This function returns this result type which has this error. We'll have to handle this error. This is the error that we should be handling. So now we go up. Where is our error? Now we will have to put a way to convert from this error into the JWT error, because that's what we return. We return this JWT error everywhere. It's very easy. You use the same of you implement the same from trait. Simple from trait. When I say same, because we have done this before. If you come down, I think we implemented it somewhere. From trait, did we implement it? Oh, we didn't. Okay, you can see the implementation here. So we implemented we implement a from trait, and we put in the error that we want to convert it from. So the error, as you saw, was base64 decoder. This error, we want this error to be converted to JSON Web Token. So this is how we do it, JWT error, and inside we will give what do we say? We just say function from, and here you just, I think here you will just say the same error. These are, we will say it like this. What do you say here? You just, I think you just give this particular error here, because this error is of this type. When you implement this trait from, it requires you to implement this particular method. This is a very standard method, function from, and this function will return, you should say self here. Self is, instead of giving a concrete type like JWT error, if you just say self, it also means the same thing, but it's just a bit more in case you happen to change this JWT error into something else, you don't have to change it here as well. Self automatically points to this. So from here, the inside here, we will give the conversion. So we will say from JWT error. We haven't created that error yet. So let's create that error. Let's call it decoder. You can call it whatever you want. Then because this variant of this enum wraps this error, so we give the error that it wraps. It wraps base 64 decoder. You give that error type here, and then you just mention that this particular, and then you return that that particular variant. Obviously it is going to complain because we added a new arm here, and which is a good thing about this Rust match statement. It forces you to forces you to make sure that it forces you to handle all the particular possible scenarios. I had almost missed handling this. Decoder, because this takes an argument, so we'll say E. Give a format here, error in decoding, decoding from, what was it, base 64, error in, let's keep it simple, base, yeah, like this, and then you say E, yeah, whatever you gave here, you give it here, and it has to be comma. Okay, we have handled the base 64 decoding error. Now we also need to handle, so we can very well use a question mark operator here. Once we have given that from conversion, we can use a question mark operator here. Then now let us handle this. This should return, let's see what kind of error this returns. We were in from UDF8 right here. Okay, from UDF8. From UDF8 error. Is this it? This is the one? From UDF8 error. I thought it was UDF8 error. From UDF8 stir. Okay, from UDF8, what are we doing here? String from UDF8. Was it from UDF8? Okay. Okay. All right. From UDF8 it is. It is stat strings. Why is the string here? Shouldn't it be stir? Am I in the right place? Why am I in string here? Steady stir. I should be in steady stir. Docs steady stir Rust. stir from UDF8 let's check here, from UDF8 steady stir, this one, steady stir. Okay, we are in a steady stir here. Okay, we are in a steady stir from UDF8. What error type does it return? Yeah, this is the right error type. Sorry, it was right here. I don't know why I went here. You have to be careful because there are two things: string with a capital S, and this stir. This string goes on the heap, and this is your slice, string slice. So we are using this one. It is UDF8 error, std star UDF8 error. We will give a conversion function for that. Where was it? Yeah, here. If you feel that doing all this, like giving error conversions like this, and then giving a format display statement like this for each and every error variant that you add here is a bit too much of a boilerplate. You can use a third-party library called this error. I think it is called this error. It's called crits.io. Yeah, you can use this library. It cuts down a lot of this boilerplate, but this is a small project, so let's do it by hand, and it will also give us a very good understanding of how we should do error handling, custom error handling. Okay, so what was the error in all this talk? I forgot what was the error type. std str UDF8 error from std star UDF8 error, and you just copy this, copy, and paste like a champ. Okay, yep, because we didn't add this arm, so let's quickly add this particular arm here. Let's call it UDF8 error, and inside here we will give undo. Let's copy this, copy, and paste. Obviously this is going to complain, right? Why the hell is this still complaining? Expected, did I not save it? Expected enum type. Oh, let me just call it decoder UDF8 error impl from. Okay, bummer. Maybe if you're watching it, you'd be thinking, why didn't he didn't he see it right away? But please consider I'm talking and coding at the same time. Sometimes I miss obvious things which would look obvious to you. Let's add this arm here. Okay, decoder, was it UTF-8 error? Yeah, UTF-8 error, UTF-8 error, UTF-8 error, this one. It does take an input. Give it a format. And so error in, let's just call it UTF-8 error. You can beautify it later if you want it. Good. And now we can replace this with a question mark. And it should be good. And last is this serde JSON. So let's go and take a look at what serde JSON. Serde JSON, serde JSON, serde JSON, serde JSON, serde JSON results from serde. Where is its error type? Serde JSON from stir. Was it from stir? Are we using from stir? Good. We're using this. Serde JSON. Using from stir. Result value. Where is the error type here? Structs. Let's go here. Error. Yeah. This should be the error. I think that's the error, right? Yeah, I think this is the error. Let's just confirm. We are using from stir, and because whenever you see this, it is an alias type. This sort of representation is an alias type. It is actually returning result t comma error. So they just create an alias type to do the same thing. When it gets compiled, it gets compiled to result t comma error. It is returning that this particular error, this one. If it doesn't, we will get a compiler error. In Rust, you can do that. So we will give a this here from, what was it, serde JSON, and then it was, the error was error. I think this was the error, right? Let's see, serde JSON error, serde JSON error. Yeah, we're good. Serde JSON error, and let's copy this. Copy this and paste the, not here, not here, not here. Paste this, then copy this. We will need it later on. So create an error variant here. Let's call it serde JSON error. And it will be of type this. Okay, let's also add a variant. JWT error, serde JSON error. Format serde JSON error. Looks a bit dumb, but I don't want to spend time carping about what should be the right string here. You can do it later if you want. UTF-8, now give it the right error type. what it should be. JWT error, serde JSON error. We're good. We're good. Okay, we removed unwrapped from here. So this particular function, we are doing proper error handling here. And now let's remove this ugly thing from here. Let's hope this will work. Yep, this will work because, yeah, the error is already handled. Let's remove this ugly thing also from here. And nothing happens. Good. Good. Let's remove this ugly thing also from here. And it is good. Let's quickly see if we got any other ugly things in our code. Okay, one is here. In test is beautiful. In test it's beautiful. Oh, okay, unwrap all, it's fine. Because it will, this is just providing a default option so that it doesn't panic. So here it's okay. Other than these, we are not doing anywhere else. We're good. Let's run the test again to see if everything works. Our test passed. We are good. Woohoo! Let's see if we need to do anything else here. Did we miss anything? We are returning JSON. We are checking JSON. Okay. We are checking the header. Let's also check the payload as well, just to be sure everything is doing good. And obviously we want to check the payload because payload is where we are sending the information. Let payload is equal to R. Okay, will I be able to do it here? Can I? I can, yeah. Yeah, because this is a raw string, so I will not have to convert it. Good, yeah. Sorry, I'm not very used to talking and typing. Sometimes I might speak gibberish. Please forgive me for that. Then we are okay. Let's do asserts here. Payload token. Payload. Yeah. Now let's run the test again. Woohoo! We are good. Our program is working. Let's make sure it works. The test works. Let's modify this. Now let's see if now it should fail. Good, it failed. It failed on UDF8 error. It gave us an error. And yeah, it gave us a proper error. It didn't just say panic and didn't know what to do. It gave us a proper error, UDF8 error here. Error value, UDF8 error, UDF8 error valid up to some, okay. Undo, okay. UDF8 error, good. UDF8 error, I think looks good. If you want, You can add some more tests here. Let's say, let me add one more test. We're almost done here. Let me add just one more test for extra unknown part test. Unknown part test, and there we will give, we will copy this and we will give one extra value here. Extra. This is an invalid JSON Web Token because if you're trying to decode, we wouldn't know what to do with this part. So we should get unknown part error. We will go back and we will parse it here. Okay. And we will not call it unwrap because we know it is going to panic. I mean, it is going to error out. This will return a result object. A result is an enum internally. So this will return the error variant of that enum because we know this is going to fail because of this. So we will check the error message. Yeah, okay, good that I'm writing this test. I wanted to show you one thing. Here you will end up with one error in our special scenario that we are writing in. Let me show you that error quick. So because this is going to give us an error, we know, and we want that error to be missing unknown part error. Let's check for it like this. You would want to do it like this. Assert, not serde. Assert EQ. Our expected error is this: JWT error, unknown part error. This is what we expect, and this is what we got from as a result of running this parser function. But first you will see this error. You will see this error. Yeah, this says this is equal operation is not implemented because we are trying to check whether these two things are equal. So this is not implemented on our error type. So let's go back to the error type. So in this here, partial X. Yeah, we're trying to compare errors, right? So we should, let's try to implement partial X here. Yeah, we want to implement partial X here. This is what you want to implement when you want to implement that equality, assert equality there. So now you will see another error here because we are dealing with serde JSON crate. In this specific scenario of building this application, we have to use serde JSON. Serde JSON library doesn't allow you to implement this particular trait. So we cannot compare the errors using assert equal to. So in this scenario, we will have to use something else. I'll just say undo here. So this you can do. We will have to fall back to our match statement to match the error. Then match, let's say, token. And then it's pretty simple. Match token so long as this token is of this error type. JWT. What was it? Unknown error. If it is this time, we do nothing. Okay, this means nothing. However, if it is anything else, then we just panic because we run a test. We can just panic. We'll use this panic macro. We'll just panic and we'll say received unexpected error, expected, what was it, unknown part error, unknown part error. Okay, now we will be able to compile it, and now we will be able to run this test, and you see it passed. And you see here, unknown part test passed. Let's go here and run the test, in case if you don't have that what do you call the shortcuts set up, then you'll be doing it this way: cargo test, and both the tests passed, and we are done. You can add more tests like missing part error, and you can also test for whether the decoding went properly or not, UTF-8 decoding. There it is debatable, because it's like trying to test the library. If the library decoded it properly, the library is already tested. The serde JSON library is already tested, so you wouldn't need to do a lot of testing. Maybe 1 or 2 placeholder tests you can put there. And that's all I wanted to share. I think, oh, we didn't run the application. Let's run the application. We did all this and we didn't run the application. Cargo run -t. Either you can say -t, or you can give it the long form token like this. Both are equivalent. -t, and then let's give that giant token here. Control Shift V. Enter. Woohoo! Decoded token, this, and it managed to decode it and convert it to JSON. This is the JSON object. This is also the JSON object, which is the same as what you have here. We are done. Thank you very much. I will upload all this source code onto GitHub, so you don't have to like what do you call, try to copy it as I code. Okay, have a good day. Bye bye.